Well, here's another example which is really a continuation of this example, where we're going to evaluate the surface integral for 2x plus 2y plus z equals 10, and x between 0 and 2 and y between 0 and 4. Only this time, instead of using our region R as a region of the xy plane, we're going to make it, we're going to use as our variable of integration instead of x and y. We're going to get the same result. We're going to use, instead of the x and y axes, we're going to let the region R be the shadow in the yz plane. So first of all, our original function, which was this, we'd need to have it solved for x. And so if you solve this for x, let me see, we'd have 2x equals 10 plus 2y minus z, and then dividing both sides by 2, we get x equals 5 plus y minus z over 2. So when we begin, we start with x equals 5 plus y minus z over 2, and our partial with respect to y equals 1, and our partial with respect to z from here equals -1/2. So we also need y and z limits of integration instead of x limits of integration, so that's different. Y limits, of course, will be the same because we're still in the yz plane, but the x limits, well, if x and y are both 0, then z would be 10 based on this equation. See, x and y are both 0, 0 is 10, z is 10. And then if x is 2 and y is 4, remember the limits of integration when we did it before. X is 2 and y is 4, so that's kind of like an upper limit for z. Then that would force z to be 14. Why is z 14? Well, remember x is 2 and y is 4, so y is 4, so that's 5 plus 4, and x is 2, so that makes 7, and so we get negative, I guess it makes -7 there, right? So then -7 equals -z over 2, so positive z equals positive 14. So how about that? Z equals 14. So integrating, here's our function, f of x, y. Our limits of integration, y going from 0 to 4, z going from 10 to 14, and the part that's under the square root is 1 plus, well, partial with respect to y is 1, so 1 squared, and then partial with respect to z is -1/2, so -1/2 squared. And then I would replace my, remember we're replacing x this time with what x is equal to, and that was 5 plus y minus z over 2. So here's the 5 plus y minus z over 2, then minus 2y plus z. Now we've got the correct number of variables, and this is just strictly a very simple polynomial integration, and I'll leave it to the interested reader to verify that this is also 216. It's kind of like the mass of this surface over, which is a plane, over this interval really, but now we've changed and used a different variable. So the yz plane is the one back here. We use the yz plane as our place, as our, well, where we divide it up into the rectangles, use partial derivatives, etc., with the yz plane.